Hi guys, how are you? My name's Dan and welcome to an astronomical video with me. So by the title of the video you probably already know what this month's episode is about. Stars. So I'm not just going to tell you what a star is because that would be a really short episode. No, I'm going to talk about the different types of star. So let's begin, shall we? So to begin with, I'm going to start this journey with a protostar. And that makes sense seeing as a protostar is what you get before a star forms. A protostar is a collection of gas that has collapsed down from a giant molecular cloud. The protostar phase of a stellar evolution lasts about 100,000 years, which is a very, 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 very long time. Over time, gravity and pressure increase, forcing the protostar to collapse down. All of the energy released by the protostar comes only from the heating caused by the gravitational energy. Nuclear fusion reactions haven't started yet. Next is T-Tauri star. I think that's how you say it. I'm not entirely sure, so I'm just going to call it T. A T-star is a stage in a star's formation and evolution right before it becomes a main sequence star. This phase occurs at the end of the protostar phase, when the gravitational pressure holding the star together is the source of all of its energy. T-stars don't have enough pressure and temperature at their core to generate nuclear fusion, but they do resemble main sequence stars. They're about the same temperature but brighter because they are larger. T-stars can have large areas of sunspot coverage and have intense X-ray flares and extremely powerful stellar winds. Stars will remain in the T stage for about 100 million years. Which, again, is a very, 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 etc. long time. Now, a main sequence star. The majority of all stars in our galaxy and even the universe are main sequence stars. Our Sun is a main sequence star, and so are our nearest neighbours. Sirius? Again, I'm really sorry about the pronunciation of these words because I don't think I'm saying any of these right. Except from, the words I'm saying right now. And so yeah, the Sirius one and Alpha Centauri, which I think I did get right. Alpha Centauri A. Main sequence stars can vary in size, mass, and brightness, but they are all doing the same thing, converting hydrogen into helium in their cores, releasing a tremendous amount of energy. A star in the main sequence is in a state of hydrostatic equilibrium. Gravity is pulling the star inward and the light pressure from all of the fusion reactions in the star are pushing outward. The inner and outward forces balance each other out, and the star maintains an spherical shape. Stars in the main sequence will have a size that depends on their mass, which defines the amount of gravity pulling them inward. The lower mass limit for a main sequence star is about 0.08 times the mass of the Sun, or 80 times the mass of Jupiter. This is the minimum amount of gravity pressure you need to ignite fusion in the core. Stars can theoretically grow up to more than 100 times the mass of the Sun. Now, red giant star. When a star has consumed its stock of hydrogen in its core, fusion stops and the star no longer generates an outward pressure to counter-react the inward pressure pulling together. Excuse me. A shell of hydrogen around the core ignites, continuing the life of the star, but causes it to increase in size dramatically. The aging star has become a red giant star, and can be 100 times larger than it was in the main sequence phase. When this hydrogen fuel is used up, further shells of helium and even heavier elements can be consumed in fusion reactions. The red giant phase of the star's life will only last a few 100 million years, but it runs out of fuel completely and becomes a white dwarf. Next up, we have a white dwarf. When a star has completely run out of hydrogen fuel in its core, it lacks the mass to force higher elements into fusion reaction. It becomes a white dwarf star. The outward light pressure from the fusion reaction stops and the star collapses inward under its own gravity. A white dwarf shines because it was a hot star, but now but there's no fusion reaction happening anymore. Now we are moving on to a red dwarf. Red dwarfs are most of the common kind of stars in the universe. These are main sequence stars, but they have such low mass that they're much cooler than stars like the Sun. They have by the way, I mean cool as in temperature-wise, not cool as in what I don't know, describe, but the other kind of cool. They have another advantage. Red dwarf stars are able to keep the hydrogen fuel mixing into their core, and so they can conserve their fuel for much longer than any other star. Astronomers estimate that some red dwarf stars will burn up to 10 trillion years. Burn for 10 trillion years. Which is very, you get the gist, long time. The smallest red dwarfs are 0.075 times the mass of the Sun, and they can have a mass of up to half the Sun. Next we are going to neutron stars. If a star has between 1.35 and 2.1 times the mass of the Sun, it doesn't form a white dwarf when it dies. Instead, the star dies in a catastrophic supernova explosion, and the remaining core becomes a neutron star. As its name implies, a neutron star is an exotic type of star that is composed entirely of neutrons. This is because the intense gravity of a neutron star crushes protons and electrons together to form neutrons. If stars are even more massive, they will become black holes instead of neutron stars after the supernova goes off. Supergiant stars. The largest stars in the universe are supergiant stars. These are monsters with dozens of times the mass of the Sun. Unlike a relatively stable star like the Sun, supergiants are consuming hydrogen fuel at an enormous rate and will consume all the fuel in their cores within a few million years. Supergiant stars live fast and die young, detonating as supernovae, completely disintegrating themselves in the process. As always, thanks for watching. Subscribe to the channel if you haven't already, and watch the next video. Leave a like, subscribe, and watch the next video like I just said. See you later. Bye.